features which supports for the object-oriented programming system. And we will also see the comparison between procedural-oriented programming to that of an object-oriented programming. So just to have a quick beginning, we will just try to understand what is an object-oriented programming system. So here, as you are looking from the slide, the object-oriented programming basically tries to remove some of the disadvantages which was encountered in procedural-oriented programming. So in an object-oriented programming, the primary focus is on data rather than the procedure. The data can be moved freely around the system, and object-oriented programming tries to tie the data more closely to that of the functions which it is going to have an operation done on it. And an object-oriented programming tries to protect any accidental modification which is done from an outside function defined by the programmer. So here the functions cannot exist without the data, and the data need functions to give it a proper shape. So just to have the better understanding, what I have just taken here in this slide is the quick relation between an organization of a data and the necessary function which comes with the object-oriented programming system. Now here I have got three objects which is being related with the necessary functions. You could observe an object A has a data, and object A again has its own functions which is defined by the respective classes. Similarly, I do have an object B which is having its own data and the necessary functions. I have at an object C the necessary data and the functions. Now, the way in which the object A, object B, and object C gets connected is with the help of a communication established via the passing mechanism. And here, the organization of a data and functions with an object-oriented programming purely depends on the message passing techniques which is adapted by the programming system. Now, the object-oriented programming allows any kind of a decomposition of a problem into a number of entities which we call it as an object, and the object then tries to build the data and the functions which is lying around these systems. And here the data is hidden and it cannot be shared by any outside functions. The data of an object can be made accessible only by the functions which are associated with the respective objects. And here the objects are then created, and the objects which are created might interact with each other with the help of functions. And the object-oriented programming system always follows the chronology called as bottom-up approach. Just because the objects are created first and the data and functions are developed later. And some of the important striking features of an object-oriented programming are listed below. The first point is, as already stated in the previous slides, here the emphasis is on data rather than procedures. And a program are divided into what are known as objects. The data structures here are designed in such a way they characterize the nature of an object. The functions which operate on the necessary data of an object are tied together with the data structure. And here the data is hidden and it cannot be accessed by any of the external functions. The objects may communicate with each other with the help of functions. And here, any new data and the functions which are defined could be easily added whenever it is required. And the object-oriented programming follows a bottom-up approach with its programming design. And we can see from this diagram, I have got an operating procedure through which an object-oriented programming could make some sense. So the basic or a core level concepts of OOCs are defined here, where I can see classes, there are objects, there are data abstraction and encapsulation mechanism, there is an inheritance, there is a polymorphism, there is a message passing. And here, let's try to understand what we mean by the term called as objects. And here, we could see objects are those basic runtime entities which defines an object-oriented system. It may represent a person, it may represent a bank account, it may represent a place, it can also represent a table of data, it can represent vector, it can represent something which is closely related to the real world objects. An example here could be name, the date of birth, age, the address. If these details are required for the student, we can just create a class called as student, and for this student, we can have an object which is related with the help of necessary variables. And here we can observe objects specifically occupy some space in the memory and it will have an associated addresses. Whenever a program is executed, the objects interact by sending messages to one another. For example, if customer and account are two objects, then the customer object may send message to an account object requesting for the bank balance. So we can see how objects contains both data and operations which aims at manipulating the data. And the objects can interact without having the knowledge or the details obtained from the system. And it is much more sufficient to know what is this type of message which is accepted, the type of responses which are returned by the necessary objects. Now, just moving further, now we can just define what are classes. And the simplest form of a definition for a class is a class is merely a collection of objects of similar type. A class can be defined as a user-defined data type where the entire set of data and code of an object can be made with the help of a respective object belonging to the class through which it gets its creation. Now let's just take an example here. I'll just define the name of the class as car, and the car may have certain methods like refuel, setting the speed, getting the fuel, driving details, and so on. And these are certain operations which could be observed on the car. And now the attributes which corresponds to this class called as car are fuel, the maximum speed through which I would be able to compute the speed of a particular car. Let's just have a continuation observed here. What we understand with this diagram is there is a class initially named as car, and to this created class we determine the actions, and those actions are set by the attributes, are set by the methods corresponding to the attributes. Then on the third part of this diagram, we see the relation of class to that of an object. For me, the object may be the car, the type of a car, along with the same methods, along with the same attributes, which is correspondent. So I've just taken an object by the green colored Mercedes, by the blue colored BMW, by the saffron color Audi. And these are the colors which is observed, the types of the car possessing the same methods with the same attributes. That's about the classes. Now moving further, uh, we will just try to understand the term called as encapsulation. And most of us know, whenever we work with a programming environment, it is utmost essential for securing the code, for just having some of the authorizations which is given to the code along with the data. And this term we call as encapsulation. I just repeat again, the wrapping up of data and the functions put together into a single unit is known as encapsulation. And here, in an object-oriented programming system, the encapsulation hides the implementation details of an object from its users. And encapsulation prevents any unauthorized access of data or a functionality. The data which is not made as accessible to the outside world are generally wrapped up inside a class, and this wrapping up we call it as data hiding or information hiding. Let's just take an example. Now, what we understand from this example is there is a view which I can relate the capsule, or maybe the pill which we just generally take. And inside this capsule, what is there, we don't know. But outside the capsule, there are some coverings, and these coverings will give a protection to the powder or a layer which is present inside a capsule. Exactly the same functionality, I can just define encapsulation with programming terminologies. Outside the class, we can just observe the necessary methods. We see the necessary variables which substantiates for the class. But what is there inside, that's the data, we generally will not have an awareness. And that concept, we call it as an encapsulation. Moving further, yet we have one more striking characteristic feature, which we call it as a data abstraction. And the word abstraction refers to an act of representing all those essential features without including any background details or explanations. And the data abstraction always separates unnecessary details or explanations such that it aims at reducing the complexity of understanding the requirements. For example, we can just see here there is a car, and this car is making use of the keyword called as abstraction. And here we can see without abstraction, there are the term called as feature, which includes the background details. So if I don't use data abstraction with an object-oriented programming, then it's quite obvious we are actually giving the separation of implementation. Meaning to say, The data abstraction always aims at referring to, to the act of representing all those essential features without including the background details or explanations. Means it's an outer layout which will be provided with the programming system, but we never know what is there inside an implementation. The other example which is taken here is there is a chip. There are the details which is given with the specifications, and there is an application which is run with a mobile. So that's a wrong way in which I see the data abstraction. Moving further, we have the next feature called as inheritance. And here, inheritance is that process by which objects of one class acquire the properties of objects of another class. And specifically speaking, the concept of inheritance provides the programmer with a term called as reusability. Means we are going to have an addition done to an already existing system, to an already existing class without modifying the contents. And that's, we call it as inheritance. And with our inheritance concept, we could see the role of a parent class to that of the child class. And whenever we have an inheritance being observed, there are certain levels which is treated with an inheritance. We have a type called as single inheritance. We have a type called as multi-level inheritance, multiple inheritance, the hierarchical inheritance, and an hybrid inheritance. And here this particular slide provides an illustration about the actual need for an inheritance and its types associated with the system. So we can see here there are parents, and for this parents there is a child, and whatever the parents is possessing, maybe the features, maybe the characteristics which determines the IQ of a child, it all would be passed, or it all would be just transferred from the parents to that of a child. So when I observe here, there is the features which are extracted referred to the base class, and the features which is obtained refers to the child class, and we can have the base class or the derived class being observed as parent class under child class. Now we can just observe towards the right hand side when there is an inheritance concept. I say like it's a mimic through which almost all the characteristic features have been passed to the derived class. And here what I mean by the features are nothing but the functionalities which is defined with respect to the actual parental class. And to understand this single inheritance, whenever I inherit or I just reuse the class A towards the class B, and there is one single parental class, and that term is single inheritance. Now, with a multiple inheritance, what we observe is there are two base classes and there is only one derived class. And with a multi-level inheritance, it's been dependent on the previous class to that of its previous class. And with our hierarchical inheritance, we do have one main class which I call it as a parental class, and I can have many subclasses or the child classes obtained from the parental class. And now we have gotten hybrid inheritance, and inside this hybrid inheritance, we can see the mix-up of single, multiple, and a multi-level inheritance concepts. Now, just let's try to have a keen observation about the next important characteristic feature, which I call it as polymorphism. And here, the term polymorphism implies it's nothing but many forms. And the basic feature of polymorphism is being adopted from the system to that of an value which we are defining. And polymorphism actually defines the ability to take more than one form. And this is that kind of a feature which will have the different implementations of a function to refer to the same name. Now, to observe the term called as polymorphism, I have just taken one real-time example. There is an addition operation which I am trying to perform on a class, and I can now see the role of addition operation on two integer declared numbers, two floating point numbers, two string defined values. Now, on the other hand, we can just see there is the person who is able to speak, and the same person can be able to mimic the way in which owl is going to do, the way in which duck is going to talk, the way in which cat is going to converse. But an actions or it is the same person is able to speak with multiple ways. And that striking feature we refer as a polymorphism. In one line, I can just tell polymorphism is nothing but many forms. Here we have the role of polymorphism being seen with its types. And clearly, polymorphism feature gives the programmer with two different types called as compile time polymorphism and runtime polymorphism. With the compile time polymorphism, we come across with two important concepts called as function overloading and operator overloading. With the runtime polymorphism, we see the concepts called as virtual functions and function overriding. And what is this function overloading? What is this operator overloading? Would be the question which we have to address. If the programmer makes use of operator overloading, then it's nothing but that process of making an operator to behave with different behaviors at different instances. I use the term called as function overloading to make use of a single function being acted upon to carry out multiple operations or tasks. Moving further, we have the term called as dynamic binding. And in dynamic binding, the code which is associated with the procedure call is definitely known, and this term which is not known would be called during the runtime. And this dynamic binding is usually associated with a polymorphism and inheritance concept. And at runtime, the code which is existent will definitely pass or refer to the current object which will be invoked or called. And here the last feature which I can relate with an object-oriented system would be message passing. And the interesting point to be understood by this message passing is there are set of objects which communicate with each other, and objects communicate with each other by sending and receiving an information. For example, a message for an object acts as a request towards execution of a procedure, and it in turn invokes a function in the receiving object, thereby generating a desired result. A message passing generally involves specifying the name of the object, name of the function, and an information which needs to be sent to the respective object. Let's look on at this slide, and it acts as an example where I have employee dot salary within bracket name, and we can relate here employee is a class, salary is a function which we are trying to invoke, having an argument being filled with a necessary variable. And here the argument which is filled with a variable as name is defined inside a class. So we can note here employee is acting as an object, salary is a message, and name which I am trying to look in this example is an information. And here the objects have a life cycle and they cannot be created or destroyed. On the other hand, the communication with an object is made as feasible as long as it's been found or present in the system. Now, I'll just halt at this point of time. Let's see clearly the actual differences between procedural oriented programming to that of an object oriented programming in the next class. Thank you all.